Now, symmetry with respect to the origin. Notice what's happening. I'm picking a coordinate point. It is being imaged through the origin, and it ends up down there. In other words, it's cross quadrant. It's cross quadrant. It's very, very hard. It's a double fold. If I were going to be folding something, it's a double fold. So that says a graph is said to be symmetric, remind ourselves, with respect to, because you're going to see me use this all the time, the origin, if for every point x, y on the graph, I've got opposite, opposite. So if you think about it, if I'm going cross quadrant, x and y's are opposites. So if I want a point which is symmetric, now remember this guy's going to go across through the origin. So that says if I'm looking at this, it's going to be what? Negative 3. Negative 3.
No.
Oh,
Negative 2.
oh, it's negative 3, negative 2. So it's 3, 2. Both x and y change. So it's negative 3, negative 2. It's hard because we've been counting, and it's hard to count when you're going diagonally. That's when you have to kind of trust the coordinate point, is when you're on the diagonal. I can't say this is fun stuff. It's kind of interesting stuff. We have more stuff that's coming. It's going to be fun. Not for a while, but it's coming. So here's the origin. So that says, if I'm going to go through the origin, this is how it's going to go. So if x, y is on the graph, it's going to be opposite x, opposite y, because I'm in a quadrant across. So in general, if x, y is on the graph, so is opposite x, opposite y. Now this is kind of interesting. This is square root. So I'm going to have to work with this sucker. I'm going to have to pull some coordinate points. 0, 0 is a good one. 1, 1 is a good one. 4, 2 is a good one. Anything in between, if you remember, is going to be some kind of a decimal. That's hopefully enough to give me a shape. So if I look at my coordinate points for square root, this is going to be 0, 0, 1, 1, 4, 2, and origin symmetric I change everybody, right? 0, 0, minus 1, minus 1, minus 4, minus 2. So 0, 0, minus 1, minus 1, minus 4, minus 2, kind of interesting, huh? And by the way, he almost looks like cube root. Cube root looks like that. But that's square root. Cool. That's the that is the opposite. That would be y equal the opposite of the square root of the opposite of x. Because you've got to change both x and y. Cool.